So our assignment here is to convert the following integral to spherical coordinates. I do not plan to actually evaluate the integral, just go ahead and do the conversions. So let's first look at dz, dy, dx. We know that's dv, and in spherical coordinates, it's rho squared sine phi d rho d phi d theta. So we'll start with that. Now, how about x and y? There's two triangles that define this for us. We have the x and y triangle from polar coordinates. Here's x, here's y, here's r, and there's theta. So looking at this first, I say cos of theta is x over r. So r cos theta is x. And then sine of theta is y over r. So r sine theta is y. So we have both x and y in terms of r, but that's not quite enough because I need it to be rho, theta, and phi. I have theta, I don't have r. But then I need my other triangle to convert. Here's z, here's rho, here's r, and here's phi. So what are we going to say here? Sine of phi is r over rho. So rho sine phi equals r. Similarly, cos of phi, no, check that, good enough, equals r. Rho sine phi is r. So if I know that now, I have r cos theta is x, and I have r sine theta is y. We're going to make the substitution there for r being rho sine phi to get x and y. So we see x is r cos theta, but r is rho sine phi. So replacing r with rho sine phi, we get x is rho sine phi cos theta. Y is r sine theta, but r is rho sine phi. Replacing r with rho sine phi, we get y is rho sine phi sine theta. So what are we ready to substitute? We know what x is. We know what y is. We know what dz, dy, dx is. So let's go ahead and make that change. See where we are. So making the substitutions, we see rho sine phi cos theta is x. Rho sine phi sine theta is y. Rho squared sine phi d rho d phi d theta is dz, dy, dx. Now let's try to simplify that a little bit. So that brings us here, the triple integral over some ball of rho to the fourth sine cubed phi sine theta cos theta d rho d phi d theta. Notice rho squared rho to the fourth sine phi sine phi sine phi sine cubed phi sine theta cos theta sine theta cos theta d rho d phi d theta. Now I need to figure out what is happening with that ball. So looking back up here at the top, what does that mean? That means z starts at root x squared plus y squared, and z goes to root 2 minus x squared minus y squared. Y starts at 0 and goes to y equals root 1 minus x squared. X goes from 0 to 1. We need to rethink that in the world of spherical coordinates. The bottom piece is z equals root x squared plus y squared. Again, z has to be positive here. Keep that in mind. So z squared equals x squared plus y squared. That is our intersecting lines. But z is just positive. That will give us the upper half of some cone. Now, how about the top? How high is that going? What's it going to? So the top portion is z equals root 2 minus x squared minus y squared. Squaring both sides, z squared equals 2 minus x squared minus y squared. X squared plus y squared plus z squared equals 2. That is a circle with, a sphere with radius equal to the square root of 2. So there is our sphere with radius root 2, and there's our cone, and they intersect somewhere. Probably helpful to determine that, so let's take a quick look. So curious for the intersection of these two. So I have z squared is x squared plus y squared. And I have z squared is 2 minus x squared minus y squared. So what does that give me? That gives me x squared plus y squared equals 2 minus x squared minus y squared. Adding the x squared and y squared to the left side, I get 2x squared plus 2y squared equals 2, or dividing everything by 2, x squared plus y squared equals 1, a circle of radius 1. Is that it? So it looks like x squared plus y squared equals 1 could intersect that circle that's up at some altitude. So if I just extend this to a cylinder, you will see sure enough it is. So that will be my region of interest inside that circle of radius 1. So what does rho range from? Rho starts at 0 and it goes until it hits that cap. And recall that cap was a sphere of radius root 2. So rho is ranging from 0 to root 2. That's going to correspond to that piece. Now, how about the z equals root x squared plus y squared? We've seen that before as well. And that is that cone. So what is the definition of that cone? What's happening there? Well, z equals root x squared plus y squared. X squared plus y squared is r squared. Z equals root r squared. So z equals r. And then we have what? Then we have our favorite triangle, which is z here, which is phi here, which is rho here, which is r there. And then what do we say about these two things? Again, cos phi is z over rho, so rho cos phi equals z. Sine phi equals r over rho. So rho sine phi equals r. Well, if z equals r, that means rho cos phi equals rho sine phi, which means cos phi equals sine phi, which means phi equals pi over 4. So this thing corresponds to phi is pi over 4, and this thing corresponds to rho equals square root of 2. So we have an idea of what those endpoints represent. So if we're going to set up our information, we should be able to see where rho is going and where phi is going. But then what about these last two pieces here? What's that telling me? Can we visualize those? Y goes from 0 to root 1 minus x squared. Y equals 0 is the x-axis. Y equals root 1 minus x squared. Y squared is 1 minus x squared. X squared plus y squared is 1. Circle of radius 1. We're starting on the x-axis. We're going up to that circle. But then x is only going from 0 to 1, which just gives me this piece. So we've already said that rho ranges from 0 to root 2. Phi is going to range from 0 to pi over 4, as we can see with our picture here. So phi is going to start at 0 and go to pi over 4, start at the North Pole and go to pi over 4. And then this is going to define our theta. So what is theta ranging from? Theta here is 0, and theta here is pi over 2. So theta is going to go from 0 to pi over 2. So looking at our picture, we do not have that fully capped cone. We just have a portion of it. So let's see it. This is what we need to have. But rho is still going from 0 to root 2. Phi is going from 0 to 45 degrees, pi over 4. And theta is going from 0 to 90 degrees, or pi over 2, and that should enable us to finish this problem. So here's what we had earlier. Notice rho is our inside integral. Rho is going to go from 0 to square root of 2 because that sphere had radius root 2. Phi is going from 0 to pi over 4, 45 degrees. And theta just gave us what? Just gave us that quarter turn. Theta is going from 0 to pi over 2.